I'm Zane Reynolds. I'm the manager of the data engineering team at Torc Robotics. Torc Robotics was originally founded in 2005, and then later in 2019 was acquired by Daimler Trucks Auto Group, and since then has been laser focused on building an L4 autonomous truck solution. The autonomous trucking space has such high volumes of data. They had all of their data and all of the compute power on-prem. It was a big, expensive system that sat in one location. And if they sent a vehicle to another area to drive, they would have to ship the data back, like physically ship drives back and try to load it onto the system. And we knew that in order to fulfill the mission for Daimler, we're gonna need a lot more scale. We moved all of our data to the cloud. My team's primary product to the rest of Torc is a data lake. So we initially started with trying to move our data from those on-prem services to S3. And we also wanted to start collecting the data directly from the vehicles to S3 as well. So that was goal number one, get everything into S3. So to do that, we migrated our data from on-prem using snowballs. We bulk migrated a lot of our existing data to S3 that way. So trucks would go out on a drive, they come back, basically pull out a canister of these hard drives, plug it into a node that streams everything to S3 as quickly as possible. That works really well for us because we have a couple of primary distributed sites, so all that data is getting funneled in. Once it's there, we do a process to make that data usable as part of a data lake, which is unpacking a lot of the data. From that point, we used lake formation to create the data lake. That gives us the central catalog. And once things are in lake formation, they connect really well to lots of other tools and services. So SageMaker is one that we use quite a bit for machine learning and model training. We also use QuickSight for reporting. So we have a lot of different use cases. I think that's where the data lake is such a cool thing for Torc to be able to have, because lots of different use cases, variable access patterns. And this gives us a nice flexible way to provide the data that's needed to all the different teams. If you're fleet operations and you want to report on what percentage of the time were we in robotic mode on this section of highway in June of this year, you can do that. If you're a machine learning team, like a perception team, and you want to find examples for your training set where the road has extreme curvature, you can do that as well. And all these capabilities weren't there prior to building the data lake. You only had that raw binary compressed data. Specifically around S3, we have been impressed with how simple and performant it really is. It was a central component to the data lake that we have built and to all the operations that we built on top of it. And we don't have to worry about S3. The benefit that we really get is that every team can move faster and can focus on the work that's differentiated work as compared to building the infrastructure that's needed to answer those questions. We want to send the vehicles out into the world to experience the world, to see what the different situations are, weather conditions, different road conditions, are there emergency vehicles, are there cars on the shoulder, etc. So the more the trucks can be out in the world and sense the things around them, the better the algorithms can be to drive those trucks, and then the safer the product will be at the end. I think having the data available in the way that we have it through a data lake created so many new capabilities. It made a big difference to, I think, every team. Every team is using the data lake now. It helps everyone move faster and can focus a little bit more on the mission that they're trying to solve.